This is number 10 on the back of the review packet. Please make sure that you read the problem well before we get started here. It says a skateboarder speeds up from rest to a velocity of 9 meters per second in 15 seconds. It speeds up with uniform acceleration. So first thing, we're supposed to draw a physical diagram. So that's drawing a picture of the situation. And on this, so I drew a girl on a skateboard, here. And then on there, we want to identify what position 0 is and what direction is positive. Secondly, we need to list the given information and what they respond. What's the starting velocity if she speeds up from rest? The answer is 0 meters per second. Our final velocity would be the velocity at 15 seconds, which is 9 meters per second. And then the change in time up there is the 15 seconds that we have up here. Next up, draw a qualitative motion map that represents the motion of the skateboarder. Now, because it's 15 seconds for the big problem, normally there should be 1 dot per second, which would be 16 dots, which is too many for up here. So we're going to build this with just 5. On here, I had the wrong number. That's for 15 seconds, but we're going to do this with 5 dots. So if it speeds up from rest, it's going to start with only a small change of position. And then the change of position has to be bigger. Since that's 1, I can make this 2. And make it bigger than that, I can make that 3. And then to make that bigger, I can go 1, 2, 3, 4. And now we've got 0, 1, 2, 3, 4 seconds. And I'll do one more of these. 1, 2, 3, 4, 5. And then we're going to add velocity vectors. Well, was it moving, or was she moving at time 0? The answer is no, so no velocity vector for the first dot. And then we have a small positive velocity, a bigger positive velocity. I went from a 1 hash mark blue line to a 2 hash, now to 3, and then to 4, and I'll make this 5 off the way. So those are all increasing size as we go. If we were to build an acceleration versus time graph, this is an increasing positive velocity, which is a positive change in acceleration. Because the acceleration vectors are all going to be the same length, I can go ahead and choose this and make all of my acceleration vectors the exact same size because it's a constant or uniform acceleration. Do you need to go to your next class?
Yeah.
You should pack up. Next up on the video, scrolling down through here, we would need a qualitative position versus time graph. Because we said that she is starting at position 0 and she is moving in a positive direction while speeding up, we have a top open curve here. Again, there's no numbers necessary on that. And then as we go down here further, she's speeding up. Her initial velocity is 0. And we know that 15 seconds later, her velocity is 9 meters per second. So I'm going to go ahead and draw a line on here connecting those points. And we go from a velocity of 0 to 9 meters per second at the 15-second mark.
You already know about free pencils.
Next up, we need to calculate uniform acceleration. In which case, you need to take the final velocity, which was 9 meters per second, minus the initial velocity of 0 meters per second, and that was 15 seconds. So you've got 9 meters per second divided by 15 seconds, which is 3/5, and 3/5 is the same thing as 6/10 meters per second, which is our rate of acceleration. To calculate displacement, you're going to want to use the area under our velocity versus time graph. So if I draw a dotted line here and we shade in that area with this up here, we can now calculate that area and it gives us the displacement. So we already said the area of a triangle is 1/2 height times base. The height of our triangle happens to be the final velocity. The base is our change in time. So displacement is 1/2. The height again was 9 meters per second. Our base is 15 seconds. Half of 9 is 4.5. I might need a calculator for this. 4.5, so 4 times 15 would be 60. half of 15 is 7.5, so that's going to end up being 67.5. Seconds cancel out, leaving us with just meters. And now how fast will the skateboarder be going at the 11-second mark? Because we've now calculated the acceleration at 0.6 meters per second times 11 seconds. The initial velocity was 0, so we can leave that off. So 11 times 0.6 would be 6.6. And as far as units go, seconds cancel out, and we get 6.6 meters per second at the 11-second mark. If we take a look back up here on our graph, if you look where 11 seconds is, which would be here, we go up and across over here, you can see that's a little bit closer to the 6 to the 8, which supports that information. Hope that helps.